No, you can use Excel, you can use online it's just for in class, Haley. That's two great questions I want to address technology-wise. First question, Riley said, I need a bit of a refresher. I need to see how to do this on the TI. First of all, the videos are now uploaded from Monday, so they're there for you. They're not indexed perfectly. I wish I had the time to actually index every single video. Right now it just says part 1, part 2, part 3, part 4. So you can kind of fast forward through and you'll find where we do the... Yes ma'am, ready for you, waiting for you. They're uploaded no more than 24 hours later. YouTube takes a while to upload, so yesterday's aren't uploaded yet, but Mondays are. Number 1. Number 2, on the extra resources page for 243, there's a link that's a statistics TI manual. You click on that, it's a big PDF document that opens up and teaches you how to do all the stat stuff that we're going to be doing in this class. Sitting there waiting for, on the extra resources page, the enrichment page. Number 2. Number 3, Haley asked a great question. Do I need to go buy one of these things? No. No, no, no. I use them in class because about roughly half of you have them. So that's why I use them in class. Online, Excel, tons of resources. On your exam that's due in 3 weeks or 2 weeks, I teach you how to use Excel to do all this stuff. I'd rather us have Excel in here. I'd rather this class be in a computer classroom. If the world according to Sean existed, we'd be sitting in a computer classroom. The world according to Sean doesn't exist yet, so we sit here. So no, please don't go spend $120 more or whatever it is to buy on the machine. If you already have it, I want to use it. We can also put them on phones. You can definitely get apps on phones if you want. You don't have to use the TI app. You can use other apps. I'd be more than happy to help you fish for one in the App Store. So just realize many, many resources exist. I want you to use whatever you're comfortable with. Cool. All right. I got my data in. I got my data in. Good. Great question. Now what? What should I do? I called you on the phone. I need to help with my homework. What do I do? Stat. Calc. One more stats. Sean said something about L2 yesterday. He said something about L2. Do I have to use L2?
Not yet.
Why?
Not yet.
Oh, because my data's in L1. Thank you. Just press enter. Okay. There's a lot of crap on the screen. Help me. Help. I lost you. Help me interpret all this.
You got the average.
I got the average. W, what's the average?
-4.
Very good. The negative 14.7. If you guys don't mind, I'm going to go ahead and call that negative 15 just to make the math easier.
Sure.
I don't like it.
So let's ignore everything. It's okay, you don't have to. But the only reason I went to 15 is because the weights themselves were in whole number increments. It seems logical to keep that no more precision than we're allowed to have kind of thing. So anyway, let's ignore everything else for a moment. What does negative 15 pound average mean? What does that mean, friends?
On average.
Tell me your name again.
Michaela.
Michaela, go, my friend.
On average over time.
Good. If we applied this study to the general population.
Yeah.
Exactly. But there were people in there that gained 6 and gained 20 and gained 12, right? So how do we account for them?
All the people who lost 50-something.
Right. It's the lollipop. It's the it's the socialist, right? It's the socialist measure. It is the social. No, it's okay. I mean, that's a good way of thinking about it, though. That is a great way of thinking about it. It's the lollipop problem, right? Except instead of giving lollipops, you're taking them away because it's negative. But it's the same exact idea. Beautiful. Now the problem is, if somebody was thinking about embarking on this diet, and they asked you, does it work? You would say, on average, people lost 15 pounds. And they might think, hell yeah, let's go get on this diet, right? But what other number would also be helpful for them to know, and why? Thank you. Alicia has told us. Everything else up here is great, but not important right now. You don't need that, you don't need that. We know this because we said that, right? You might go with the median. Which is negative 17, which is actually pretty close to the average anyway. But I want to focus on this number today. Woo. Standard deviation, 16 pounds. That's what that guy means right there, right? Your sample standard deviation is about 16 pounds. I want to know what that tells us. So now you already know what the average tells us. Andrea is going to tell us what 16 pounds means. Go ahead, my friend.
That you could deviate from negative 15 by 16 pounds.
Yeah. In fact, who does deviate from negative 15 to 16 units?
That gained weight.
Oh, that's true. That's true. But if I start the word with the average distance, the wrong thing to start it with. Interpret the 16 pounds over the entire data set. I love what you're doing, because you're saying if you deviate away 16 pounds, you're now into positive territory. So if you go 16 up from 15, you're now at positive 1 and you gained weight, right? I want to come back to Alicia's point on this one, though. You had a good point about 20 minutes ago. I want to come back. Please, Riley.
Is that like the margin of error?
Yes, that would be if we applied it inferentially. Thank you. I want to get back into that too today, maybe towards the end of the day. Good, hold that thought, okay? We are never far from the margin of error, ever, in this life of ours. But this is just the sample I'm looking at right now. So Andrea, you took a, is it Andrea?
Andrea.
Andrea, okay, good. I love if you go 16 up, you're now into positive territory. What if I go 16 down? I'm in more negative territory, right? So what exactly does the 16 mean again? What distance? The average distance from where?
From the average.
Boom! That's what we learned yesterday, right?
Yeah.
We learned that the average distance from negative 15 pounds is 16 pounds. So yeah, sorry about that. Yeah. One person lost 58, right? 58 pounds is down like 40 pounds from this. But one person only lost, say, 8. They're only down 7 pounds. And one person gained 1. They're up 16. All those numbers are different, right? But if you average all those distances, it averages to 16 pounds. Is that fair? Terrence, you buy that?
I was saying that's so freaking cool.
Isn't that badass? I think that's badass. It's a neat way. And remember how on that slide I put big and little? When S is big, data is varied. When S is little, it's not varied. What I want to do is I want to kind of get close to, okay, so we know it's average 16 pounds. What does that tell us? Can we fuse Alicia's very logical percentage with this? And the answer is yes, sometimes, if the data is shaped a certain way. So what I want us to do right now is I want us to check the shape of this data. Who can close their eyes right now and imagine what this data would look like if we drew a graph of it? Close your eyes. Your eyes are open. Close your eyes. Okay, you got an idea? What are you imagining? The last time I told you to do this, I drew you a goofy-ass bimodal graph. Remember that? So what are you imagining right now in your mind? Bell curve? A bar graph? What's the shape? Is it a rectangle? Is it triangle? Is it kind of double? Bell curve in your mind? Bell curve in your mind? Maybe not. Maybe you're not sure. Maybe you're like, I don't know what the hell I'm supposed to think of. You're telling me to think and I don't know what to... Please.
Bell curve.
Corey?
Yes.
Corey, thank you.
Bell curve further to the left.
Oh, a bell curve with a teeny bit of skew, center to the left because the average is negative. Did you hear what Corey just said? A bell curve moves to the left of the y-axis because the average is negative.
Is that any skew, right?
Well, I just said move to the left. It would be skewed. Well, the skew is independent of where the average is. If it was skewed right, it would be leaning. You know what? Let's just look at it and see. Right? Instead of trying to guess what, let's look at it and see. Good? I think you got to be right, Corey. Because if the average is negative, it has to be humped over on the left side. The question is the hump leaning? I don't know. Let's find out. So let's go over here and let's learn how to draw a histogram on this thing.